Hello again, everybody. I trust you all enjoyed your lunch. Thank you very much to the staff at the Hilton and Temple Patrick for looking after us so well. But too well, they keep feeding us and we don't want to come back into the room. But if you could grab the coffees and the buns as quickly as possible, because we're going to move into our second session of the day. And the second session is the role of animal health in achieving our environmental goals. Once again, I have a very easy job as I'm going to hand over to the brilliant Dr. Alistair Douglas, Director of Veterinary Sciences Division at the AFBI, who is going to chair this session for us. Thank you, Alistair.
Thank you, Sarah. I'll make sure the £10 note for that compliment is in as an envelope for you. It's my great pleasure today to be able to chair this session of the AFBI Outlook Conference, particularly in the role of animal health in achieving our environmental goals. By way of introduction to this session, there is obviously a very clear link between animal health and welfare with productivity, but also with environmental sustainability. Healthy animals which are free from disease have a positive impact on productivity, but also they have an impact on emissions and the environment. There are challenges though, such as climate change, biodiversity losses, the need to reduce greenhouse gas emissions, the need to reduce our reliance on antibiotics, and the impact from that of antimicrobial resistance. In the talks today, I hope we can give you some insight into what's being undertaken within the animal health and welfare space that can have a positive impact on our environment and also our animals. So we have three excellent speakers today. We have from Morden Research Institute, from AFBI, and also from the Institute of Global Food Security at Queen's University Belfast. Our speakers are going to share important information, data, and policy perspectives with you in this particular area. So, without further ado, our keynote speaker is Dr. Philip Skoos from the Morden Research Institute. I've known Philip for 30 plus years, 30 years at least. Philip is principal scientist at the Institute, which is over in Edinburgh, having worked there for the last 25 years on various aspects of sustainable control of helminth parasites, worms and fluke in livestock. His research interests are in parasite diagnostics, detection of the environment, vaccination studies, and the detection and management of resistance. He also has interests in conservation, grazing, the impact of climate change on parasite epidemiology, and the impact of endemic disease on carbon footprint of livestock production. He is also the Safari Scottish Environment, Food and Agriculture Research Institute Gateway Knowledge Broker for Livestock. And I believe he is going to share a secret for those of you that do not know him. So without further ado, I'd ask Philip to come up to the stage. Thank you.
Well, thank you very much, Mr. Chairman. Alistair, yes, I can't believe we've known each other that long. It's an absolute pleasure to be here. I'm delighted, indeed honoured, to be on the platform today. So I'd like to thank AFBI for the invitation. And it's also nice to be home. And by home, I mean the Hilton Temple Patrick, because this is the third time I've spoken on this stage this year. So you're obviously doing something with conferencing. And secondly, the secret, I do have to apologise to half the people in the room who very graciously said hello to me this morning, thinking I was my twin brother Robin, who actually works for AFBI on bovine tuberculosis, and he's sitting down the back there. I even grew a little beard to try and make sure people could tell us apart, and they still called me Robin. So I'll apologise for that. But yes, delighted to be here. And just to say something about linking animal health to our environmental footprint, and it's not all just about carbon and methane. There is a bit more to it than that. Just to say a little bit about myself, just to be very selfish, I'm a graduate of Queen's University Belfast, a parasitologist by training, so Alistair's obviously seen my notes. I did actually work at VSD for 2 years with Stuart Taylor, very nice man. in parasitology and had very happy memories of that. So it caused some confusion then, and it's still causing some confusion now because the chap in the photograph is not me, that's my brother. But I've been at the Morden since 1995, and we were 100 years old 2 years ago. So I hope you've heard of us. I'd be absolutely gutted if you haven't. Our remit is around sustainable control of endemic disease in livestock, and our core business is around vaccines, diagnostics, and disease control strategies. We've a very nice new institute. Well, it's not that new now, I guess. It's 15 years old, on the outskirts of Edinburgh. Nice place to live and work. But I'm also the Safari knowledge broker, the gateway knowledge broker for livestock. And for those of you who've never heard of Safari, I don't recognize the acronym. It's the Scottish Environment, Food and Agriculture Research Institutes, and involves ourselves, Morden, but also SRUC, which some of you will know very well, the James Hutton Institute as well, and various others. Plus, we've now got 5 centres of expertise, including climate exchange and EPIC, and disease epidemiology. So hopefully these will be familiar names to you, so that the institutes plus the centres of expertise. And we're very lucky in Scotland that the government are very supportive of science. They understand science. Okay, it means we have to co-construct policy-relevant research, but that's a good space to be in, and livestock are right in the middle of that. So just to reframe the topic of today around carbon and beyond, and just some of the global challenges, the checks and balances around livestock. I mean, there's no doubt that livestock are affected by a changing climate, both directly and indirectly, whether they're indoors, outdoors, or in transit. But also they're subjected to challenge by different pathogens that also their epidemiology, their seasonality, their geographic spread changes with a changing climate. But the impacts of those pathogens can also impact directly on greenhouse gas emissions and the efficiency of the animal, as Alistair said at the outset. And there's also the biodiversity loss, the sort of twin challenges now, looking at, livestock are certainly thought by some to contribute to a lot of the world's environmental problems through pollution, deforestation. Some of that is global and it's not necessarily applies here, but it's something we have to bear in mind. But also they can be very efficient ecological engineers, and that we're starting to see that. And I was very interested in some of the talks this morning talking about agroforestry and silviculture and starting to have animals and trees instead of animals or trees. So they can provide food and homes for large numbers of invertebrates, and they fertilize the soil, and I think I'm preaching to the converted here. But just to say a little bit about the policy context, and I'm not sure if it's as political here. I mean, most things usually are in Northern Ireland, but there have been a number of important groups that have sat and discussed and reported on this general topic area in the recent past. Top of the list there is the UK Climate Change Committee, but also in Scotland we had a Farming for 1.5 Degrees independent inquiry. There was also the Scottish Government set up a series of sectoral groups, including a beef suckler climate scheme, dairy group, and a hill, upland and crofting group. The World Wildlife Fund in Scotland also reported on the future of farming in Scotland. The MAC, we heard that this morning from one of the previous speakers, marginal abatement cost curves for Scottish agriculture also include animal health, and that's important to see that. And the UK-wide Ruminant Health and Welfare Group, and some of you in this audience are members of that and contribute to that, also have been looking into this. And finally, the CL report that Elizabeth alluded to earlier on, all identify livestock health status as a key constraint on efficient production and a mitigation option for reducing greenhouse gas emissions. So there's a lot of reporting and discussing. So, I mean, to bring some of that back to the sort of the health aspects of it, the OIE some years ago reported that morbidity and mortality caused through animal disease was responsible for an approximate loss of about a fifth of our production globally. That's quite challenging. And it can take the form of exotic diseases, which we all know all too well. We remember foot and mouth and various other things that are African swine fever that are happening as we speak, can cause huge losses and really devastate the industry. But I'd also make a case for endemic diseases. These can also cause huge losses. They're production limiting by definition, can lead to death, poor live weight gain, abortions, reduced milk yields, and things like mastitis and Johne's and parasitic gastroenteritis that you'll all have heard of. But high herd and flock health status is thought it will contribute and help us reduce the losses and also improve production efficiency and help mitigate the greenhouse gas emissions associated with animal agriculture. The one thing I would say is there isn't a huge amount of empirical data to support that. It seems very intuitive, and I'm going to leave that there to some extent because Ilias, who's just leaving the room, is an emissions expert and will unpack some of that information for you. But just to say a little bit about some of the work we've tried to do, and being a parasitologist, I automatically think to the parasites first, but it's really around, in this case, the impacts of gastrointestinal parasites or worms on production and associated emissions. And we've done a lot of this work in collaboration with Scotland's Rural College. They've got some fantastic facilities just beside us. But as a group of diseases, they're a major constraint on efficient livestock production. They cause inappetence, so have a very direct effect on how well an animal will grow. They cause poor feed conversion efficiency, and we heard a bit about that this morning, called ill thrift as well, to use a nice Scottish term. So what we've done over the last few years is combined field studies where we're looking at actually growing animals in different paddock trials under different treatment regimes. Also abattoir data, looking at what's the implications of disease status when the animal gets to the abattoir. And also chamber studies, which is very much in the gift of SRUC. They have some fantastic respiratory chambers, like Stephen mentioned at Hillsborough, and we can put parasitized animals in those chambers, acclimatize them, and then directly measure the emissions. So there's a number of options here. So we're measuring emissions, we're modeling emissions, and we're back calculating emissions. But we see a significant reduction in emissions associated with sustainable parasite control, and it ranges from 10% to 30%, depending on the metrics. And I say Ilias will unpack some of the metrics for us. But that's to do with effective and sustainable worm control in cattle and sheep. The same applies to cattle as to sheep. And just to mention my favourite parasite, and I know it's a bit of a problem in the wetter west of the country, around liver fluke, in this case in beef cattle, using large abattoir data sets to look at the fluky animals when they get to the abattoir. So the guy with a very sharp knife there is calling whether those animals are fluky or not, and is there historic or fresh fluke infestations. So what we've done, and I'm not numerate enough to do this, but we collaborate with the people who are, is to apply robust statistical analysis and greenhouse gas emissions modelling to work out what's going on here. It's easy to say the fluky ones, the fluky cattle are a month older and they're several kilograms lighter, but it is not as simple as that. When the statisticians get involved, you start to realise the caveats and confounding factors around that. And these include the sex of the animal, the breed of the animal, the age, the holding they come from. So what we've tried to do in one study was a meta-analysis of all the published reports on what fluke does to animals. That's complicated too, because some of them are experimental challenges, some of them are natural infections, some are cattle, some are sheep, some are different breeds, some are indoors, some are outdoors. So that's complicated too, but you can take it from me that there is a significant impact. Some studies suggest there isn't much, others suggest there's quite a lot, but there is actually a statistically significant 9% hit on daily live weight gain and a lower live weight overall. But also, just to bring it up slightly more up to date, we've done an abattoir study with 250,000 beef cattle in the northeast of Scotland. I thought that was quite a big data set until I talked to the numerate people who think that's quite a small case study. But we were able to look in that data set, and we're still working in this area, and there's a significant 4% reduction in the daily live weight gain of those animals, and it takes them an extra 11 days to get to slaughter. And that's statistically robust information. That's not just the guy with the sharp knife telling me. And there's a back-calculated 2% increase in emissions associated with a live fluke infection. And that's most likely a significant underestimate, because these are the healthy animals that have made it to the abattoir. There are lots of losses along the way, as you all know too well. So that information's published as well. And we've been encouraged recently by the Scottish Government to have a look at BVD. They set up a BVD eradication scheme, which is almost reaching completion. There's one or two stragglers still hanging on, but it's been a very successful program. and very well thought of and adopted through the industry. I think it had a difficult birth, but it's getting there now. So they're looking to see what have the implications or the impact of improving the BVD status of the Scottish herd been on the associated emissions. There's a famous quote from the Scottish Agricultural Secretary at the time when he was trying to sell the scheme that it would reduce emissions by 3%, but nobody can tell me where that figure comes from, and everybody in Scottish Government hides when I ask them. So we're actually trying to put some figures on that to see what the impact has been. So we're working with EPIC, which is the Centre of Expertise in our system that works on epidemiology. Using similar abattoir data sets, we can use their BVD status, we can track where they've come from, we know their production impacts when they get to the abattoir. So that's kind of what we're doing now, using Scott EID, cattle tracing, and BVD data to estimate not just the impact of BVD on the persistently infected PIs, but also on their herd mates. What's the fate of animals in herds that have a BVD non-negative status? So that's a work in progress, and as I said at the top, I thought fluke was complicated and BVD is only a virus. Sorry, Louise, that's a bit insulting. But. So, as I said, there was a lot of chat and discussion around animal health, and maybe more heat than light, to be honest, but we took it upon ourselves to establish a livestock health and greenhouse gas special advisory group. One of the things the Safari model allows us to do is small amounts of money for knowledge exchange programs, and this is what we did. So we brought together, and it was one of the benefits of COVID, I guess, was that we were all locked in our bedrooms, but it meant you could get over 100 people on a call discussing greenhouse gases and animal health, which you would never have done face-to-face. So that involved researchers and farmers, but also the livestock industry, government policy teams, so we were really very fortunate to get that mix in the room. And around the same time, this UK-wide Ruminant Health and Welfare Group had conducted an online poll of its membership, asking a grassroots survey of disease priorities. So they were trying to rank diseases. Are they biosecurity risk? Are they a trading risk? Are they common diseases? So that's the grassroots survey that was happening at around the same time. So the one person who's right in the middle of this, and some of you might know him, is the thoughtful chap on the right-hand side of the top panel, Nigel Miller, former past president of the NFU Scotland. He's the chair of the UK, of the Ruminant Health and Welfare Group, and he said, look, we really should be talking to each other and come up with something tangible between these two groups. So working with Ruminant Health and Welfare, we were keen to unpack what do we mean by livestock health in this context, in the context of emissions. And around that time, and all the talk of COP27, we were hosting COP26 in Glasgow. So the timing was pretty good. This is a good chance to produce something tangible that might get some traction at around that time. So one of the early things that came out of COP, one of the few things that came out of COP was a global methane pledge to reduce methane by 30% by 2030, signed up very quickly by the United States and Europe. It was really aimed at the waste and landfill and energy sectors, but that doesn't stop the press running with a picture of a cow in the UK, because that's obviously where all the methane comes from. But it was a time for us to think about, well, could we produce something tangible that would be useful? And I hope it is. We produced a report called Acting on Methane, and it unpacks the diseases we're talking about, tries to rank them in priority order, and reflect back some of the discussions that are going on at a high level. And I apologize to the people in the room. It's a big room. It's hard to see things. But one of the first things we tried to do was understand what are the things that push the buttons for emissions. And the key three things that really turn the dial would be higher growth rates, would be better feed conversion efficiency, and less involuntary culling. And you can see the reasons for that in the slide as to what that does. It reduces days to slaughter. We heard that this morning. It reduces levels of inputs, and it also reduces replacement rates. So then the idea was, could we map those metrics against the different diseases that we're concerned about? So that's where this horrendous table came from, and I apologize, it's not meant to be viewed on a slide in a big room. It's meant to be perused at your leisure, ideally on screen or in print. So the idea was to looking across, so cattle conditions, we've got sheep conditions, and we've got a group of parasitic infections. And the idea is just to read down, and you can see how the different things in terms of growth rate, feed conversion efficiency, involuntary culling, and then how prevalent are these diseases? What have we got in terms of diagnostics and screening programs? What have we got in terms of treatment and prevention options? And how is the disease recognized? Is it a animal health and welfare priority? Is it an EU priority? How's that done? So we've tried to capture a lot in a small table. One other thing that was very evident to me, I was told quite early on that it's not just about disease, it should be around syndromes as well. Lots of farmers and vets deal with syndromes. We're fixated on our individual favourite diseases, but that's not how the industry works. So the aim of the report was really to engage farmers, vets and advisors around discussions of animal health in the context of emissions, and it's something we can do now. I think it's a really positive message. This is something we can do now. Breeding and feeding strategies are fantastic and there's real potential there, but they're going to take a little bit of time to come in. So the idea was to give cattle and sheep farmers options for improving good practice at farm level. So that's vaccination programs and improved biosecurity, diagnostic testing, optimizing treatments. We heard some of that this morning. But also to give the industry and the government, at a very critical time actually for the sector, options to encourage good practice at a sort of an industry level. So maybe identify one or two priority diseases or health conditions at farm level, but also consider something at a national level as well. And that's the space certainly Scottish Government are in at the minute. So just to pick up and just to finish on a little bit of a sales pitch for Morden and come back to some of our core business. So what are we doing in terms of animal health in a changing climate? Well, one of the things we've done recently is to develop the world's first vaccine for a parasitic worm in sheep, selling like hotcakes in Australia, where they've got all sorts of problems. It's Barbervax against the Haemonchus contortus, a very voracious blood-feeding nematode. And that's one of the very few anti-parasite vaccines anywhere. We've also developed a diagnostic test for sheep scab, which can tell if animals are infected long before clinical signs appear, and it's being used as we speak in eradication schemes on the Scottish Islands. And over here in Northern Ireland, you might recognise Sam Strain, a very small version of Sam on the right-hand side, and Paul Crawford and a few others involved in that. But also in terms of disease control strategies, we're starting to look at automated targeted selective treatments, so we optimize our wormer treatments. So rather than just treating every month because it's a certain month with a product that you always use, it's much more fleet of foot and flexible. So we're targeting treatments using precision livestock technology, so ear tags and weigh crates, and that's starting to gain some traction. So really reducing our chemical inputs, and that's good for the environment too. And just on the sort of the environment biodiversity side of things, I have been doing a bit of work myself on liver fluke risk around agri-environment schemes. It's something we hear about. Are we creating habitats to make fluke worse? Well, I think there's an argument that might seem to be the case, but it's not actually true. If it's properly managed, that's manageable. We can have a win-win there. Also in terms of GI parasite control, and we heard about this morning, the multi-species swards, that sort of thing's really interesting. Lower inputs, reduced anthelmintic usage, because some of these plants have natural or physical properties that parasites don't like. And the whole thing around regenerative farming, moving animals around, using them in and amongst trees. And finally, reducing the use of veterinary medicines. And I don't mean just reducing for the sake of it. I think maybe optimizing is a better term, because they do have adverse effects on the environment. And it's no surprise they're designed to kill invertebrates, and they will. They'll kill dung beetles and things that are really, really important, little ecological engineers that fertilize the soil, break up habitats, all that sort of thing. So we're interested in targeting treatments and test, don't guess, all these sort of simple things. So dung beetles have become our new thing. So just to finish and to summarize, it's encouraging now that animal health is seen as a priority and a viable mitigation option for reducing emissions. High herd and flock health status is seen as a way of realizing the potential of breeding and feeding. There's no point in having these fantastic feed additives, NOP and all the rest of it, if the animals are not in particularly good health. That's important. It's the same with breeding. And it's timely because the ongoing discussions around the future of agriculture, both here and Scotland and the UK. As you know, there's a lot of talk about public goods. And DEFRA, certainly in their animal health and welfare pathway discussions, are looking at what can we embed in that system to encourage good practice. And Scotland are the same. They've got an even worse acronym that was called the ARIOB, which is the Agricultural Reform and Implementation Oversight Board. What a mouthful that is. But they're doing something very similar. So talking to government, talking to policy teams about how do we encourage the best practice around animal health. So I think we need to acknowledge livestock's environmental impact and do what we can to reduce that, but at the same time recognize the role of livestock in sustainable agricultural practices. I mean that in the broadest sense of the term. And I hope I haven't overstayed my welcome, but I'll just leave a nice image of some sheep grazing on seaweed on the Isle of Mull. And the only downside with that is I'm reliably informed it's the wrong sort of seaweed to reduce their emissions. So apologies for that, but it's a nice picture. So I'll leave that there and thank you for your attention.
Thank you, Philip, for a very informative and interesting talk. I know we're under a bit of time pressure because Philip has to get to the airport. So without further ado, we move to our next speaker, which is Dr. Barry McInerney. Barry works at VSD. He's originally from County Clare, and he qualified as a vet surgeon from University College Dublin in 1996. He's been in practice, large animal practice then, for around 10 years in County Limerick, then returned to UCD to complete a full-time master's degree in bioprocess engineering technology, and then took a PhD position in UCD looking at food and food animal safety and traceability in the poultry food chain. Barry, you don't look old enough to have done all this. You're wearing well, I'll say that for you. He then joined Norbrook GB Limited as a European technical veterinary advisor, and after a stint at Norbrook, he has come to AFBI as our head of disease surveillance investigation branch. Barry, can I invite you to give your talk now? Thank you.
Okay, thanks Alistair for that lovely introduction. I think it's working at AFBI keeps you young, I think so it does, you know, that's what it is. Thanks Alistair, as I say, thanks to the organisers for the opportunity to speak here today, just to talk about an AFBI perspective on animal disease control and surveillance. Sorry, on here. Yeah. So, as Philip mentioned, poor animal health is a major constraint on livestock production and a significant cause of excess emissions. Controlling, managing, and eradicating endemic disease in particular has multiple significant benefits, increasing efficiency, profitability, productivity, and critically from a global perspective, reduce the need to use antibiotics with less disease, positively impacting the AMR issues, and in terms of today's conference, reducing environmental impact. So disease surveillance, just a quick summary description, is a continuous systematic collection, analysis and interpretation of animal health related data, which here in Northern Ireland is primarily generated through post-mortem testing, through submissions from PVPs and farmers, and additional diagnostic testing on submissions as well. Crucially, it provides evidence of disease presence or absence to support certification for export of animals and animal byproducts out of Northern Ireland. It also serves as an early detection system for incursions of exotic disease, which could have major impacts and catastrophic effects on the national agri-food economy here in Northern Ireland. The recent avian flu outbreaks, African swine fever as it creeps ever westward across the continent are issues which we should all be aware of. It also serves as an early warning system for new emerging diseases such as Smallenberg disease, which you'll be familiar with over the last number of years, and also an early detection system for changing endemic disease patterns. AFBI work closely with our surveillance colleagues in DEFRA, APHA, and also in Scotland with the SRUC, and also with colleagues in the Department of Agriculture, Food and Marine in Ireland, which culminates annually in our All-Ireland Annual Disease Surveillance Report, which is published on our website. At AFBI, we have 2 post-mortem facilities in Northern Ireland that feed data into the disease surveillance system. one located at Oma, covering the west, and the second post-mortem facility at Stormont, covering the east of the province. The post-mortem rooms are supported by a number of specialised laboratories, including histopathology, which is looking at tissues under a microscope to detect minuscule changes indicative of disease, bacteriology, virology, parasitology, and biochemistry. All these labs produce disease data which underpins the disease surveillance system and so the agri-food sector in Northern Ireland. Each lab is supported by highly trained and specialised staff. From a cattle population of about 1.68 million and a breeding ewe population of about 968,000 in Northern Ireland, we receive approximately 2,500 post-mortem room submissions each year. Approximately 55% of those are bovine, about 30% are sheep. The remainder are made up of poultry and pigs, with a smattering of camelids, alpacas, and even marine mammals. In addition to the PM submissions, though, we also receive large numbers of diagnostic samples direct to our lab from veterinary surgeons, mostly made up of blood samples, but also fecal samples and other tissue samples. We are also heavily involved in the BVD eradication programme here in Northern Ireland, and we test approximately 330,000 ear notch samples every single year. Looking at the findings on submissions through our post-mortem rooms in 2021, the tables in the next couple of slides will show the conditions that we've most frequently diagnosed in cattle and sheep by age group. So as you can see there, in young calves, enteric infections are the most common cause of death, which we detect in about just over 40% of our submissions. When we consider all the fecal samples that we've received, both through our post-mortem room but also directly into our labs, rotavirus was the most commonly identified pathogen, actually, at about 32% of submissions, with cryptosporidium following closely behind at about 31.7% of submissions. E. coli, K99, and coronavirus came in then third and fourth at about 8% and 4.4% of submissions, respectively. This pattern mirrors the pattern actually of 2020 as well, very much mirrors that same pattern. In older calves, on the second line there, you can see that respiratory infections made up the majority of the diagnoses. Mycoplasma bovis was the most commonly detected pathogen in about 25% of cases. Mannheim hemolytica and Pasteurella multocida made up 15-11% of submissions, of diagnosis of submissions. Several cases of parasitic pneumonia were also detected, and in terms of viral pathogens, BRSV, bovine respiratory syncytial virus, was the most commonly recorded viral pathogen, closely followed by IBR, PI3, and BVD as well. The last line there, then, looking at weanlings, I suppose unsurprisingly, pneumonia was the most frequent diagnosis in those submissions to our post-mortem room. Parasitic pneumonia due to lungworm actually made up about 23% of the diagnosis in those cases. Mycoplasma bovis was also detected in about 20% of the cases, with BRSV the most commonly isolated viral pathogen again. Interestingly, just on that one, it is interesting to note that in 14.3% of cases that were submitted to our post-mortem room, we actually detected clostridial disease such as black-legged botulism were diagnosed. I guess that's interesting from the point of view that we have a very effective very effective clostridial vaccines that have been in the market for a number of years. So it is interesting that we still continue to receive, quite high numbers of clostridial infections. Next one then. So then moving on to adult cattle then, again, respiratory infections made up the most of the diagnosis again here in about 21.6% of cases. And in 23% of those cases, Mannheim hemolytica again was the most common pathogen that we isolated. Again, that was followed by Mycoplasma bovis again at about 12%, and then a number of cases of parasitic pneumonia, which is an emerging problem in adult cattle, and also viral pneumonia, such as IBR and BRSV. In lambs, parasitic gastroenteritis, Philip mentioned worms earlier on, that includes worms, pneumatodirus, and coccidiosis, was the most common cause of death in submissions for post-mortem rooms in that age group. And then similar to adult cattle, in adult sheep as well, respiratory tract diseases were the most common cause of death. However, the most common diagnosis within that group was parasitic disease and Yagsiete, or OPA. The conclusion, I think, from this data really for us is that we see common things commonly, and many of these conditions actually can be controlled and managed successfully at farm level, particularly through detailed herd health plans. Philip mentioned earlier on, optimizing control for parasites, diagnostic testing, screening, tailored vaccination plans can all contribute to helping to reduce these disease burdens and these diagnoses on farm. Excuse me. So how do we go about controlling disease on a farm then? Well, herd health plans, biosecurity and vaccination are really the three cornerstones of good disease control. They're interlinked, they're codependent, and so in any successful disease control program, all these need to be addressed adequately. Robust and effective herd health plans require the input of not only the farmer and his or her vet, but also other professionals involved on the farm, the day-to-day management of the farm, such as farm advisors, nutritionists, hoof pairers, fertility scanners, etc., all need to fill into an effective and robust plan. They should detail and record really up-to-date disease records. They should detail disease screening plans. They should capture all diagnostic testing results. They should set clear objectives and aims at farm level and should be reviewed on a regular basis to ensure against the targets that are set and to address any emerging diseases or issues that may be arising at farm level. The herd health plan should clearly address all aspects of management of the farm and management and husbandry of the herd and the flock. For example, a key aim in any herd health plan should be to ensure adequate colostrum intake, adequate volumes, and colostrum of adequate quality for every single sheep and calf born on a farm. That is absolute key to the long-term health of cattle and sheep, of any animals born on farm. Interestingly, we have found that in 47% of calves that were submitted to us through our post-mortem rooms, 47% of them had inadequate colostral immunity. So I think that says quite a bit, It should also detail the approach to common farm procedures to minimize stress on the animal. Stress in the animals has a real significant negative effect on the immune status of the animals, opening them up to overwhelming infection. So it is key that all these issues are detailed in herd health plans. The second cornerstone then, biosecurity, should address first of all the prevention of entry of disease onto the farm by considering how best to deal with the high-risk activities at farm level, such as purchase of animals, how to deal with visitors on farm, the use of shared equipment, and the spreading of slurry from one farm to another. Biosecurity should then also address minimizing spread of infection on farm once it arrives on farm. Through the use of, again, detailed herd health plans, the use of isolation quarantine pens, and crucially, hygiene, cleaning, and disinfection of farm buildings, pens, and equipment. The third cornerstone, then, vaccination, is absolutely a key tool to control disease, but it is not in any way a substitute for poor husbandry, hygiene, or biosecurity. Also needs to be remembered that effective vaccination is significantly depleted where animals are stressed due to poor husbandry or concurrent procedures such as transport, castration, and dehorning, all of which greatly reduce the response of the animal to vaccination. It is also depleted where, due to poor hygiene, the burden of disease challenge overwhelms any immune response that you're trying to elicit by the administration of a vaccine. There are many sources of advice and information to enable farmers in Northern Ireland to successfully develop and implement strategies as part of a herd health plan to control disease effectively on their farms. There is extensive advice available not only from farmers' own vets, but also from AFBI vets and scientists in the form of reports and discussion of reports on diagnostic tests afterwards, and also from other stakeholders in Northern Ireland, such as, to mention just a few, such as DERA, CAFRI, AHWNI, etc., etc. AFBI itself offers the Checks Accredited Cattle Health Scheme, a voluntary membership programme providing pathways to control, manage and eradicate the 5 main endemic diseases that affect cattle in Northern Ireland. It's Iones, IBR, BVD, Lepto and Neospora. AFBI also continues to provide a wide spectrum of disease research programmes, looking at, for example, diagnosis and epidemiology of bovine TB, emerging poultry disease syndromes, early diagnosis of mastitis, the use of feeds, diets to prevent and treat disease, and we're heavily involved in, and Philip mentioned it earlier, the Northern Ireland Sheep Scab Control Project as well. So, in terms of disease control opportunities in Northern Ireland, AFBI ourselves, as I mentioned earlier, we provide extensive diagnostic services, not only for endemic and new emerging diseases, but also for those disease challenges that require emergency response because of the acute, destructive and catastrophic impact that they could have on the agri-food sector here in Northern Ireland. Diseases such as avian flu that we're currently dealing with, but also, as mentioned earlier, African swine fever as it moves ever westward on the continent. These services that we provide help to improve and enhance biosecurity both at farm and national level. There are extensive research, educational, knowledge transfer initiatives dealing with biosecurity in conjunction with, again, stakeholders in Northern Ireland such as DERA, HWNI, Agri-Search, CAFRI. So one that springs to mind that you may be familiar with is the avian flu biosecurity checklist that DERA are consistently putting out there in the public. There's also a very nice AHWNI project that has just been, that AHWNI are just starting to lead, the farm research project looking at modelling farm infection risk. So again, some very nice work going on. In the space of vaccination, again, AFBI have a long history in the development of effective vaccines such as the PCV2, porcine circovirus 2 vaccine, and have some ongoing programs looking at respiratory vaccines in cattle and pigs. In trying to, I suppose, tackle successfully disease at farm and national level, we do, however, face quite a number of challenges in terms of our national herd and flock. The changing disease patterns due to climate change, which we see particularly with parasitic disease, I think at the moment, wetter summers and milder winters present prolonged period of challenge from these diseases for our flocks and herds. We see both diseases earlier and earlier every year in our post-mortem rooms, and with climate change, there is now increased risk also from vector-borne diseases such as Schmallenberg and blue tongue. We need also, I think, to focus on the wider benefits of herd health plans, not just from efficiency and economic and health and welfare point of view, but also the positive environmental impacts of effective plans and the benefits in the fight against antimicrobial resistance in reducing the need to use antibiotics. There needs to be further focus on the management and control of endemic disease, reducing mortality, but also, again, as Philip mentioned, the number of animals that are affected by any given disease. There are, again, as mentioned earlier, extensive range of knowledge, tools, supports already available, which can have significant environmental, economic, and indeed social benefits with high levels of adoption. Can't finish without mentioning epizootic and new and emerging disease. Avian influenza is taking up quite a bit of my time at the moment, and I know it's taken up a lot of farmers' times at the moment, causing a lot of worry across Northern Ireland. And we will continue to face these epizootic and exotic disease risks such as avian flu, such as blue tongue, such as African swine fever, and we must work to ensure that we continue to reduce the risk of incursion of those diseases. Or in the case, I suppose, of avian influenza, where it's already here, that we work hard to minimize the spread of infection into and between our commercial farms. And finally, just to mention again, antimicrobial resistance, the challenge of dealing with this global One Health emergency is and should be an absolute priority for everyone. I think just by way of final comment then, I think we need to embrace and action the opportunities that these challenges bring with the tools and knowledge currently at our disposal, as we continue to try to innovate, as we've heard from previous speakers this morning, to find further solutions to combat the climate change crisis, at which we're at a tipping point. In order to achieve this, I believe we need to ensure that we support everyone that's involved in the sector to adopt and adapt. Thank you.
Thank you very much, Barry, for that very enlightening talk. Our last talk in the session is going to be given by Professor Ilias Kyriazakis of the Institute of Global Food Security of Queen's University. Ilias is a veterinarian by training who specializes in the effects of animal management on their performance, the ability to cope with challenges such as pathogens and their environmental impact. He's worked with a variety of animal species ranging from mice to cows, but more recently his research has focused on beef cattle, pigs and poultry. His team is responsible for benchmarking the environmental impact of UK pig and poultry systems and for developing mitigations to reduce the impact of these systems. They currently focus on methodological issues of quantifying the environmental impact of livestock health issues. He was co-author of the CL reports on net zero carbon and UK livestock. Professor Kyriazakis is recipient of several awards, including the Leroy Award for European Federation of Animal Sciences, for International Excellence in Animal Science, and the Fellow of national and international bodies. Ilias, I invite you up to give your talk. Thank you.
Thanks very much for the introduction and for the opportunity to present what has been occupied my thoughts for the last 2 years at least. So when you are dealing with the quantification of the effect of animal health on greenhouse gas emissions, it's very useful to see the problem as a mass flow problem, and I will explain what I mean by that. In this slide, I'm giving the example of an energy flow within an animal system, but it can be a lactating animal. The problem is identical, and I'm using energy as the mass flow, but you can replace energy with nitrogen or phosphorus. If you are interested, for example, on nitrogen excretion, the same principles would be applying. So we have inputs into the system, here called the total combustion of energy in the feed. So you have an input, and then we have an output. The output is what is retained in the body. So it's either retained as protein or as lipid. And then between these two, we have things that are lost or wasted. And they are lost either as direct emissions, like the methane in the environment, or they are lost as emissions through the feces. Okay? So effectively, the problem then is to predict what happens in the middle. Now, let's see what happens when you are dealing with this problem and you apply it to animal health. And thanks very much to Philip for setting up, and to Barry for setting up this problem very nicely for me. In terms of inputs, you know all very well what are the inputs that we have in the system. And so animal health, paradoxically, is accompanied, animal challenge is, health challenge, I should say, is paradoxically accompanied by a reduction in food intake. This is a characteristic of all infectious diseases. And of course, because you have to control the disease, you need to have inputs in terms of medication and things like that. Now, what does the disease do to the outputs? I will come back to the middle point. Then you have a reduction, as you could expect, in the production or the quality of the output. The carcass might be fatter, the milk might be also has less fat or whatever. And then, of course, you might have a reduction in fertility and increased reproductive loss from the animal. Now, what happens to emissions? Because we have a reduction in the absorption and the digestion of nutrients, more nutrients are lost either directly or through the feces. Then you have increased mortality and increased production loss, and from an emissions approach, you need to account for these two, because any animal that is culled or is dead, it's effectively a waste. Yeah? So that's quite important to remember that. For the middle part, where the challenge is, because we don't have a lot of data at the moment, we really need to convert this waste, in inverted commas, into emissions. And in order to do that, we use the Intergovernmental Panel for Climate Change, IPCC, emission factors. For those who are not familiar with IPCC, IPCC is a United Nations body. It operates with an agreement across governments, and effectively they set up emission factors in agreement and consensus based on scientific inputs. And everything that is calculated about environmental impacts, not only agriculture, is based on IPCCs. Okay? So IPCC uses 3 different emission factors, and there is a kind of a trade-off what emission factors you use. You have from the simplest to the more complex ones, and of course the converse, because they are simplest, they contain a high degree of uncertainty. Now, what happens when we apply these emissions factors to animal health? Then if you are using the tier 1, which is the most simple emission, it is fixed values per head. It doesn't matter whether you have a cow, whether you have a sheep, or whether you have a pig. A consequence of that is that the only way to reduce greenhouse gas emissions is by reducing animal numbers. Not really very useful in our case. The second one is the tier 2, which accounts for different production systems and different animal managements, and the change in the emissions factors you might have over time. And this, for example, might take into account for a dairy system as opposed to a beef system. And in theory, it can estimate the effects of animal health on emissions only by making comparisons between the health and the diseased state, and this is important. So it's very useful to make comparisons. What happens if an animal is diseased, or a flock is diseased, or a herd is diseased versus the healthy state. And the third one, which is the very detailed, it accounts for changes in animal management and animal productivity as a consequence of intervention, and intervention may actually include treatment or culling or whatever. And this is the only way that we can estimate the impact of mitigations, like mitigations for animal health. And this is very important because people very often, motivated by the right motives, are using emission factors and they reach wrong conclusions. And I will use 2 examples to demonstrate the point. This is from a very famous project funded by DEFRA, and it looked at the effect of a variety of animal health conditions in cattle, in dairy cattle, compared to the healthy status. So the brown bars are the effects of health, what is the increase in greenhouse gas emissions when you are affected by the variety of the conditions, and the yellow bars are the impacts of the mitigation. And you can see that they assume that some diseases like jaundice contributes quite a lot to greenhouse gas emissions. Some diseases like calf pneumonia or calf diarrhea contributes very little to greenhouse gas emissions. You are allowed to do that as long as you don't forget that the relationship between animal health and greenhouse gas emissions are not linear. And this is very important, and people tend to forget. And this work was based on tier 2 emissions. It's probably right. Now, what you cannot do is this work, which was the next step of this project. This is a slightly complex slide because it shows what is the impact of a variety of diseases plus the impact of a variety of mitigations on greenhouse gas emissions, and it also takes account into the cost per unit of greenhouse gas emissions abatement. Okay? So the width of the bars tells you how much greenhouse gas is gained, and the height of the bars tells you how much you gain per unit, how much financially you gain per unit of greenhouse gas abatement. So where you really want to be, it's actually the left-hand corner in the graph, where the value is negative, because the more negative the value, the more financial gain you have per unit of greenhouse gas abatement. So that suggests, for example, that you can gain quite a lot of benefits if you use vaccination for IBR, whereas you don't get any benefits if you use, for the BVD, you use actually, where is the BVD? It's there. If you use biosecurity, you don't get any benefits, and actually it's quite costly. Okay? Please don't take into account this graph because it is actually wrong, because they have used the wrong emission factors. And unfortunately, the motivation of the authors, and I suspect DEFRA was right, but this work has never been published exactly because of the issues that I have just mentioned. So, given this background, together with one of my very close collaborators, we effectively proposed a roadmap of what we need to do in order to get it right. Because when it comes to animal health, intuitively, as Philip said, you expect to have gains. It's a gain-gain situation. What you do not know is the quantification, and there is quite a lot of arm waving about it. And of course, it would matter very significantly what kind of mitigations you choose. If you want to have major effects on the reduction of greenhouse gas emissions, you need to do it right. So what we suggested 3 very simple things, and I was very pleased to hear from Barry that AFBI already does 2 of these things. So first of all, we need a knowledge of the epidemiology or the epidemiological models, to have epidemiological models for an animal health challenge. And please remember that we cannot really see a flock or a herd as a separate entity, because what might happen in one farm might affect what might happen in another. Okay? So we need to scale these models to national or regional levels. That's something doable. Then we need to know how the disease affects the outputs at a variety of scales. And we have data about that. Barry mentioned very nicely about some of the data they have. Stephen did exactly the same. But we need to know, which is not captured by many of our monitoring schemes, we need to know about condemnations and culling. We need to know about these wastes. And the most important, and this is where we lack data, is to understand the impact of animal health on food intake and utilization. Because as I said earlier, this inhibits our ability to estimate methane emissions from feed conversion, and it also inhibits our ability to estimate methane and nitrous oxide emissions from the manure. These are the minimum that we suggested. Of course, you can make the situation more complex, and you can have the icing on the cake. You might want to account for the effects of animal health on product quality, exactly for the reasons that I said earlier. You might want to consider environmental impact beyond greenhouse gas emissions. We all have the focus on greenhouse gas emissions, on carbon emissions, but the FAO itself says that actually for many systems, we should actually be looking at other kind of emissions, like nitrogen or phosphorus emissions. So let's not lose the whole picture. And of course, we need to integrate economic considerations to produce recommendations for the most effective mitigations through decision support systems. And here on your right, I have put the paper. Whoever wants to see it, please send me an email, because unfortunately it is not publicly available. Now, gratifyingly, a year later, the FAO produced this lovely report, which was entitled The Role of Animal Health in National Climate Commitments. And again, it was motivated exactly from the same basis. It said, well, okay, we expect to have benefits by using animal health as a tool to reduce improvement of animal health, to reduce greenhouse gas emissions. And interestingly, it was very gratifying to see that several of our recommendations were actually directly in the report. Some of them were very obvious. And FAO said that you need to do three kinds of things. You need the activity data, including mortality and culling, the effects on product quality and discarded products. So you need actually to include, if you throw away milk because of mastitis, you need to include it in your calculations, and you need to include it in the impacts on the fertility rates. Some of these things, we don't capture them at the moment with the systems that we have in place. Then we need to know the changes in requirements and intakes due to animal health. And this is obvious. You need to know how you need to feed the healthy animal in order to calculate what happens in emissions of the diseased animal. And lastly, but not leastly, you need changes in the emission factors due to ill health and the effects on feed utilization and digestion. And this is very difficult because we don't have this. Of course, I'm very encouraged by some of the talks I saw today from our AFBI colleagues. AFBI is in a unique position to actually address some of these gaps. And I hope that there are plans in the future to contribute greatly in that. And I also hope that they will see some small input from Queens. Thank you very much.
Thank you very much, Elias, for that very interesting talk. I believe Philip is going to make a dash for the airport, so just on behalf of the conference and the delegates, thank you very much. Yeah. I believe his brother Robin is doing the high-speed transfer at the airport, so I'm hoping they don't get stopped for any traffic violations. Otherwise, we'll be a very confused police officer as well. So could I now invite Barry back up to the stage? Elias is here, and also our panel members. Firstly, Dr. Sam Strain, who's making his way up. Sam's the Chief Executive of Animal Health and Welfare Northern Ireland. Next is Dr. Maria Galbenzu Gonzalo, And here she comes, and she is Animal Health Ireland's BBD and IBR Programme Manager. And finally, Dr. Mark Little, who is Fane Valley veterinarian and Senior Vice President of BVA Northern Ireland. Thank you very much. Welcome. And I'm going to try and negotiate Slido here. There's a few questions have come in. So I suppose, Mark, for you, is there a proven link between long periods of winter in housing and high prevalence of respiratory disease? Easy question to start with.
So is there a proven link between long periods of housing and respiratory disease? Yeah. Short answer, not that I know of, and I don't know of all the research, but every year is a different challenge. And I think myself about practical scenarios on farm where there's high incidences of respiratory disease. And it's often associated with weather conditions. It's associated with poor ventilation in the house, and it's associated with warm conditions, and particularly at housing time. So whether the long housing has something to do with it, I would say it's more the climatic conditions, and you would get a peak incidence, and Barry would be fit to tell me better at certain times of year, but particularly at the housing period. And I'm thinking about these times where you go on to farm and, you know, it's moist, it's damp, it's warm. You visit a farm and the cloud is almost in the house because it's so moist and damp, and those are the times, the risk periods. So if you have those risk periods over and cattle are in a house longer, it makes a lot of sense that if cattle are housed longer over those risk periods, there would be an increased incidence of bovine respiratory disease. Short answer, I'm not sure if there's any evidence, but common sense, and from what I see in farms, would make a lot of sense that if they're housed over those risk periods, yes.
Thank you. Sam, one for you. I did warn you I'd give you one question. So producers are facing lots of priorities. With so much to address, is there a hierarchy, and what are the things that they should do first?
Yes, that's a very good question, an important question. So if I can criticize people like me, vets, we tend to focus on individual diseases. So we've come along with BVD and maybe IBR and then maybe Neospora and maybe Iones and ... and very quickly farmers get war fatigue. And I think that's maybe at the back of all of that, because the one resource that farmers in particular have least of is time. So I think one of the ways of approaching animal disease is to try to turn things on its head, which is to think about more generic risks. So we're talking about infectious diseases in particular here, and it's already been mentioned, animal diseases move typically in animals. It's a buy one, get one free, or buy one, get several free. And so that biosecurity risk is quite generic across a range of diseases. And similarly, if we think about farm management, a lot of the farm management controls we're thinking about diseases, things like pneumonia, for example, is reducing moisture in the air, improving hygiene. So disease that I'm interested in, Iones disease, how that's controlled is all around the hygiene around the cow calving and the maternity pen and the cleanliness around those baby calves. That's important for Iones disease, but it's also true for calf scar and numerous other diseases as well. So my suggestion would be that perhaps where we should be focusing on are those generic risks and putting numbers around them as well. So looking at how many animals are brought in from how many herds, what is the disease status of those herds, are there quarantine facilities coming into those herds, what's the hygiene scores in those herds. Those are generic approaches to disease control with the hope that they would help not just one disease, but actually a range of diseases as well.
Okay, thank you, Sam. Maria, one for you in your Animal Health Ireland hat on. How can we help bridge the gap between scientific recommendations, which are sometimes complex, and the uptake by farmers to change on-farm management practices?
Yeah, that's a very important question. That's something that we're very much aware, because in Animal Health Ireland, although we are certainly involved in the research because we believe in evidence-based changes to the programs, we're also very aware of the need to to be able to influence farmers and vets and help people to make those changes. And in fact, one of the things that we've done recently is to have a clinical psychologist within our team to help us develop better, not only our training programs, but also to help vets then to convey and have those conversations on farms. So it's from the top first getting the evidence that we need, and then making changes to the programs that we can actually communicate, and that can be really make it to try to make changes on the ground.
Okay, thank you. Barry, one for you. How does the animal health disease status of Northern Ireland, coming from our surveillance, compare with that in other regions, and what does that tell us from a Northern Ireland perspective, what our priorities should be?
Yeah, so we are involved very much so now, and there's an increasing request from us to share data with our UK colleagues in particular. There is a forum that meets every couple of months where we look at initiatives around sharing data. One of the issues that we face with sharing data around endemic disease in particular is that the information that we get sometimes from vets in our submission forms, the format of that disease and the format of the way that we collect it is very different from the format of the way disease is collected with our neighbours in England, Scotland and Wales, for example. So for any of you that are familiar with disease surveillance, the APHA, who are kind of the lab section of DEFRA, if you like, they have an excellent dashboard in which they put all their data on. They gather data in a very set way. They look at that data in a very set way, and they've put a lot of resource actually at creating dashboards around that data. So if you wanted to look at, you're a farmer in Cheshire, for example, and you wanted to look at what's the incident, what's the most common thing that affects calves aged, under 1 month, for example, you can literally go onto their dashboard. You can say, I want to look at calves in this region and this age, and I will look at this disease. And it allows you very much to delve down into the nitty-gritty of that data, So there is ways to compare data, if you like, and I'm not sure there's a benefit really to comparisons necessarily, because different farmers, different territories, different countries will have disease priorities, but it allows a farmer to see, well, what are the risks in my area? Because of the way we collect the data here in Northern Ireland, we are working with the APHA. We are part of a project at the moment, like looking at sharing data, and we have shared some small bits of data with them for them to data cleanse to see, can we fit it to a similar type of dashboard. So there are efforts ongoing, I think, Alistair, to look at what common disease threats are, as opposed to necessarily comparing what the disease threats are from one country to another. I think we're quite close together. We actually face similar threats. But yeah.
And from your perspective, what do you think the future challenges we are going to have from climate change?
Yeah, I definitely think, I mentioned it, I think, in my talk. I think changing disease patterns. I also think, interestingly, and it's come up in part of this discussion, is one of the questions there, and I should have mentioned it in mine, one of the challenges, in controlling disease and looking at disease more holistically and the way it can affect the impact the environment and AMR and so on, is actually that social science. And I heard your clinical psychologist talk, actually, Maria. She was excellent about the initiatives that they're taking. I think that social science of supporting people to adopt and adapt is a big challenge.
Okay. Elias, one for you. Do we have an urgent need to calculate Tier 3 emissions factors for Northern Ireland if we are going to meet our greenhouse gas targets?
You can do some things almost immediately. And one of the things that you can do with the data that exist or are at hand is to calculate effectively to estimate a hierarchy of diseases and what they contribute in terms of greenhouse gas emissions. This requires only a tier 2 data. And then you might take a decision, but some will tell me whether this approach is right or not. You might take the decision and say, well, actually, in terms of greenhouse gas emissions, I really want to control this disease rather than another disease. That might be one approach. For the tier 3, what matters is the mitigation. That's why actually you need the tier 3 data. You need to decide if you are going to affect the national inventories, or you need to decide which mitigation is better than the other. And for this reason, we need a tier 3 calculations. Whether we can go with the first approach or not, we've got all the data we need actually, and we can do it much in a simple and very quick way, I think.
Okay. I have a question which I was thinking about this morning, because we heard this morning about, I suppose, the use of genetic improvements to lower methane production in cattle. But I'm wondering is, and anybody can, this is a wild card for any of you to pick up, how does that then factor in with disease resistance if we go down this genetics route? And are we at risk of doing something that might compromise disease resistance?
Can I have a starter for 10 on that one?
You may. I didn't want to nominate you,
and
but
the others can come in. So, just I suppose a couple of thoughts. I mean, the genetics piece is a really important piece for the agri-food industry here in Northern Ireland to embrace. We see what's been done in the south and other jurisdictions. That development, that improvement of the genetics of our cattle is really important for lots of reasons. But included in that is the carbon footprinting piece. My one caveat around it is that genes only work in an environment. So an animal is living in an environment. So those genes will only express themselves provided the environment is conducive. So if I can give you sort of a ridiculous example, imagine you have animals that are genetically extremely well programmed to have a high feed conversion rate and get to slaughter rate quickly, which is what we want, obviously. If those animals are suffering from endemic pneumonia, for example, then they're never going to achieve that genetic potential. So we have a risk of perhaps falling into different silos, the geneticists in one corner, people like me, the animal health people in another corner, nutritionists in another corner, housing specialists in another corner. But actually we need all of those people working together because these things all factor in the genetics. So that'll be one thing to say. The other thing to say is that genetic resistance for sure exists for the range of diseases that we have, and it'll vary from disease to disease. And increasingly that is going to be one of the tools in our armory. We do have to be careful that we're not inadvertently selecting for something we don't want. But we have the tools now to allow us to do that. That was something we worried about a long time ago, but I think it's less of a worry now because we have the tools to address that.
Okay. Elias?
I'm not an animal breeder, but I know that breeders now select for broader breeding goals, as they call them. This means that they have learned the lesson of the 60s or 70s that productivity is not the only genetic trait they should be selecting for. And increasingly in the genetic selection indices, they include animal resilience. So how does the animal perform when they're exposed to disease? So effectively, we've got some says, and he's absolutely right, they do take into account animal resilience and how the animal will perform when it's faced with a challenge. This indirectly will have effects on the greenhouse gas emissions. So I'm extremely, extremely optimistic about what genetic selection goals are actually doing now.
Okay, thank you, Elias. Barry?
Yeah, again, I think Stephen mentioned earlier on in his speech actually about genomics and genetics and so on, and that it is a slow burn, but it is cumulative effect, like in that, so it is. So I think that's important to remember. You know, I am optimistic as well about what genetic selection can bring down the line in terms of disease resistance and resilience and improving immune response and everything like that. I am optimistic about that. I think we do have the tools now, but I do think we need to remember that it is a long, slow, cumulative burn, and it is not an immediate solution, but it is part, again, I think Sam mentioned it, about, you know, it's taking all the tools we have together. Don't get isolated into one or the other. But yeah, optimistic about what it can bring in that field.
Okay, for your last question, and this one's round the house question, we'll start with Mark. If there is just one thing each panel member would like to see implemented which could improve things, what would it be?
Yeah, very hard question. If there's just one thing, the big gap I see as a vet is data capture on farm, and feeding in the data to see what exactly is happening and when it's happening. And if there was a way to really easily, really simply, and really quickly record that data on farms, such as an app, which you can do in 2 or 3 clicks, doesn't have to be complicated. Some of the best data capture forms are the shortest ones, but it still has to be complete, allowing us to feed in what exactly is happening on farm. I was asked to contribute to a project recently to reduce antimicrobial resistance on farm, and I said, well, where are you using your antimicrobials? And that was a big point which was missing. So I didn't know where to start because I didn't have the data. I didn't have the info, and moving the data onto some information. So being on farm and accurately recording data to get information about where to start and putting the best changes into place, be that genetics, be that management, be that medicines, or be that nutrition.
Okay. Maria?
Okay, well, following on that, I think it is massively important, because I think that there is already a wealth of data there from the diagnostic services, from milk recording, from the mortality that is recorded in AFBI, etc. Agree that there needs to be more and easier ways, because I think what we need to do is to start using that and talking to vets and farmers to see what will be useful, what do they want to see, is it early warning systems, is it benchmarking to other farms, and I do agree that would be a big change, because I think if people see where they're at in comparison to their peers, that might encourage certainly some to improve systems, so yeah.
Okay. Barry?
Yeah, so in my sphere, looking at it with the surveillance hat on, I think, reflecting on what Mark and Maria have said, but also what a lot of the talks have said this morning, you know, that science is key. Science is underpinned by data. So the quality of the data that we can collect, the quality of the data and the amount of data that we need to collect improves. Looking at it needs to improve. From my own point of view, you know, very selfishly thinking of what comes into my branch on that, I would love to see the amount of info that appears. We miss a lot of records. I saw a question on the Slido there actually about, it was about the stat around colostral immunity and that, and did I know, was it dairy or beef or mixed or whatever, you know, I just happened to see that question on the Slido. Through our post-mortem room we can do that, because the farmer has to come into us and we can therefore ask them a lot of questions. But actually, a huge majority of samples that come into us for tests come in through the post with the submission form from the vet. And the quality of the data there sometimes maybe isn't quite as good. And we continue to encourage people to say, look, improve your data, because the data that we receive for the vet allows us to improve our discussions with him around how we can control and manage that disease for his farmer in that very specific instance. But from a surveillance point of view, it allows us to gather better data that we can share with colleagues, that we can look at in detailed epidemiological point of view, to actually make really good decisions. So again, I think it's around data. I would agree with sort of Mark and Maria that it's around data for me. And that for me is an easy fix, and it's low cost. It's no cost, in fact, in that particular instance.
Thank you. Elias?
If I can add to the theme of data, and I fully agree with that, one of the major issues is the quality of the data and how the data is collected and how it's going to be used. I will give you an example what I mean by that. A year ago, AHDB commissioned my team to see what was happening with the e-medicines book for pigs in farms in England and Scotland. And their idea, which was a wonderful idea, was to connect the e-medicines book, the Red Tractor databases, and the Real Welfare database, and actually see what happens in the use of antibiotics in pig farms, whether it correlates with daily practices and things like that. From 50,000 records, it's almost embarrassing to say we were able to use only 2,000. And this was because it was almost impossible to connect the different data sets. And this was because different people were not communicating with each other. I need some water, yes. That's fine, thank you. Yes, they were not communicating with each other, so the data was not usable. And one of the lessons that we learned from the exercise was exactly this, that these three groups of people who are collecting extremely valuable and extremely interesting data need to speak to each other a little bit more. So that's my point.
Thank you. And the final word from you, Sam?
Okay, so the final word's going to be the fifth time saying the same thing, more or less. So it is about data, and it's actually about benchmarking herd health planning, benchmarked herd health planning. So every farmer has to do herd health planning. It's often done poorly. It's often done as a thing seen as something that has to be done for farm quality assurance or red tractor. We think we can transform that. So we have a concept, Barry mentioned a project called FIRM, which is Farm Infection Risk Management, and it's exactly what Elias is talking about here, which is trying to pull in information from APHIS, so things like animal movement information, mortality information, abattoir surveillance information, on-farm risk assessment information, medicine sales information into one place to provide an informed, pre-populated herd health plan for farmers, vets, and their advisors to go to and look at and assess. Because herd health planning is basically about what happened in the past, what worked, what didn't work, and what can I do to change the story going into the future. That's herd health planning. And the key here is using information, reliable information, robust information that already exists out there actually, into one place to provide bespoke herd health planning for farmers to reduce disease.
Thank you, Sam. I'm mindful that it's tea break time, so I'd like to thank all the participants in this session, and also thank you, the audience, for your attention. And I'd like to hand back now to Sarah. Thank you.
Thank you so much to Alistair, all about the data. Okay, no break, I'm afraid. You literally will have to grab the teas and coffees, and I believe there are some very tasty cookies out there too, but you must come straight back if that's all right, as we'll move on, because we don't want to be keeping you here beyond 4:30 today. You wouldn't thank me for that either. Okay, we'll see you shortly.